We build all this amazing communication technology to connect with each other, to send information, to make things clear. But what happens when those very systems start to fight each other, when they create more chaos than order? Today, we're diving into a really strange paradox, where the tools we design to communicate are actually the ones causing all the interference.
All right, so just to give you some context, what you're about to hear is part 3 of a 5-part series. All of this info comes straight from an incredibly detailed report by the experts at RFI Detectives. They're part of Virtualization Options LLC. And for this one, we're zoning in specifically on what they uncovered in Chapter 3.
So yeah, that brings us right to the heart of the mystery, doesn't it? It's a world where the very things we built for clarity are actually the source of the chaos. And that's the paradox we're digging into. What happens when good signals go bad?
Okay, let's treat this whole thing like a crime scene. Picture this. You've got a perfectly good radio service. Could be your GPS, your Wi-Fi, maybe even something critical like air traffic control. And all of a sudden, it's just garbage, static, and noise. So you go looking for the culprit, right? But the interference, it isn't coming from a busted microwave or a buzzing power line. Nope, it's coming from another communication device.
And this quote from the RFI Detectives report just nails it. It's like something out of a thriller movie. The call is coming from inside the house. The very systems that are supposed to be putting out clean, clear signals are sometimes the ones trashing the airwaves for everybody else. So how does this actually happen? I mean, really? Before we can start pointing fingers at the culprits, we've got to understand their methods. It all comes down to a very specific kind of problem, and it's called transmitter-based radio frequency interference, or RFI for short. Yeah, transmitter-based RFI. To put it simply, this is when a device that's supposed to be sending a signal on just one frequency starts, spewing out a bunch of other junk signals that cause all sorts of headaches for other services. So the real question is, how does it create all these disruptive signals in the first place? Well, it turns out there are 3 main crimes these signals commit. First, you've got what's called spurious emissions. Just think of these as ghost signals that pop up on frequencies where they have absolutely no business being. Second, there's intermodulation. Now this is kind of like a terrible DJ mixing 2 perfectly good songs into a third, awful noise that just ruins everything. And third, you have out-of-band signals. This is just a transmitter that can't stay in its own lane, bleeding over and messing with its neighbors.
All right, so now that we know the how, let's take a look at the who. It's time to profile the usual suspects behind this transmitter-based interference, all laid out for us in the report. According to the RFI Detectives, these troublemakers fall into 6 major categories. So, let's meet them.
First up in our police lineup, we have the spurious emitter. This is basically any transmitter that's generating those ghost frequencies we were just talking about.
So its crime, essentially, is noise pollution. A transmitter is supposed to operate on one specific frequency, right? But if it's malfunctioning or just poorly designed, it can accidentally start broadcasting on totally unrelated frequencies, causing bizarre interference sometimes miles and miles away.
Next, we've got a much sneakier culprit, the intermodulation mixer. This one's tricky because it doesn't act alone. It's actually the result of other signals combining.
You find this happening in places that are just jam-packed with signals, like on a cell tower. 2 strong, clean signals can mix together on some random component, and it could be something as simple as a rusty bolt, and poof, they create a brand new interfering signal. It's a phantom menace that nobody even transmitted on purpose.
Our third suspect is the out-of-band offender. And honestly, this one is just a really bad neighbor.
It's supposed to stay nice and tidy inside its assigned channel, but instead, its signal just spills everywhere, right into the channels next door. This is usually a dead giveaway that an amplifier is being pushed too hard or a filter isn't working right. It's literally stepping on the toes of the signals right beside it.
And finally, we've got a whole gang of suspects that we can kind of group together. These aren't defined by a specific kind of signal they're putting out, but more by their behavior. So let's just call them the unruly operators.
Now this gang covers a lot of territory. First, you have authorized services that are just plain operating outside the rules, like a radio station broadcasting with way too much power. Then you have the true outlaws, unlicensed devices, things like cheap drones or wireless video gadgets that completely ignore the regulations. And finally, you have any transmitter that's just not meeting the technical standards it's supposed to.
So after going through all these suspects, what's the final verdict? What's the big takeaway from this whole investigation into our noisy, signal-filled world? Well, the report really boils it all down to two main groups of culprits. On one side, you've got the authorized systems that are just behaving badly, they're broken, set up wrong, or being pushed way too hard. And on the other side, you've got the completely unruly, unlicensed devices that are just operating out in the wild west of the radio spectrum, causing all kinds of unpredictable trouble.
So I think the crucial point here is this. This kind of interference isn't just a bunch of random accidents. It's a fundamental challenge that comes with living in a world that is completely soaked in wireless technology. Managing it takes constant, hard work, from the engineers who design the stuff to the technicians who have to keep it all running.
Which kind of leaves us with one last question to chew on. As our world just gets louder and more crowded with wireless signals, the real challenge isn't just about sending more data faster. It's about how we protect the most critical signals, the ones that guide our planes, run our power grids, and save lives, and how we make sure they can always be heard above all the noise. Something to think about. Thanks for tuning in.